The space perceived as empty by the observer is a different concept from the idea of motion. For empty space to exist seems to make no sense to say that empty space had a beginning, arose, initiated, was created at the origin of the universe, because this is an idea and it was absolutist, since it, as empty space, cannot move or present any kind of movement. If empty space moves in relation to the observer, then it is no longer the concept of empty space, as we are already talking about a field of forces. In order for the empty space to increase in size or expand, some kind of movement would necessarily be required. If empty space could move in relation to anything, if it presented some kind of movement in relation to anything, then we are no longer talking about empty space, which always seems to be at rest in relation to the observer. Only if the space is completely empty with respect to the observer, if it no existed in the universe, or if it were not physically possible for us to perceive it, a discussion about an origin of the universe would have some relevance. Either there would have been an origin of the universe and the completely empty space would not be perceived by the observer, or there is in the universe the empty space and there has never been an origin of the universe. If empty space exists in relation to the observer, the universe never had an origin. It has always been, as it is eternal and infinite. The two things, a theory about an origin of the universe and empty space existing, are not compatible things. Being rigorous from the point of view of logic, they are two ideas mutually exclusive. There is the physical observation that in any region there is always a microwave background radiation that some suggest would be a proof of the origin of the universe. Physically, we can completely nullify any type of radiation through the use of a wave source. In practice, we can nullify any force fields we wish. If, performing this experiment in the laboratory, we were able to make empty space appear in a vacuum tube, free of significant force fields or subject to some measurement, the hypothesis of the origin of space and the origin of the universe is therefore discarded. Being the existence of empty space and the absolute expansion of space incompatible ideas, have no rational reasons to admit that empty space has absolute boundaries where it ends and that these boundaries are expanding. Empty space does not serve as a reference for the state of absolute rest in the universe, simply because there is nothing else absolute in it that could serve this purpose. Empty space is incapable of telling us whether we are in motion or at rest in relation to itself. Admitting that we are always at rest with respect to empty space is never an invalid idea, like we saw and we will see in more details. At any speed at which a material body moves in relation to other bodies, it is always in a perfect position of rest in relation to empty space. Because empty space is continuous, nothing suffers friction, nothing can rub against empty space, which is in perfect agreement with the theory of relativity. In order to overcome the differences to equality between electromagnetism and gravitation, between the electromagnetic force and the gravitational force, it is necessary to compare how much an electromagnetic field accelerates an electric charge left in it in relation to how much a gravitational field accelerates this same electric charge that has mass when abandoned in it. This experiment has already been done and revealed that electromagnetic fields are much more intense than gravitational fields. They are more agitated, contain much more movement. Although protons and electrons have quantitatively different masses, both are accelerated in exactly the same way when left in the same gravitational field. When a mass of matter travels in a straight and uniform motion through space, it never stops unless forces contrary to its motion are imposed on it. We can assume in this situation that the neighboring objects are at rest and it is the mass that is in rectilinear and uniform motion. The completely physically equivalent situation is to admit that it is the mass that is in perfect rest and that the neighboring objects are moving in rectilinear and uniform motion in the opposite direction to the first situation. But the interesting situation occurs in the varied or accelerated motion. In uniformly varied motion, we can assume that a mass accelerates while its neighboring objects are at rest. The completely equivalent situation is to assume that the mass is at rest while the neighboring objects accelerate in the opposite direction to the first situation.